Welcome to another tutorial. Here we're going to look at some of the questions that you expect to prepare on as far as paper 2 is concerned. This is just a concept paper that enable you to prepare for your paper 2 exam very well, and I wish you the best for this coming exam so that you can be able to achieve your dreams. Before I start, if you are new to this channel, consider subscribing so that anytime I upload a video like this, you get notified. Now we need to start with the first question. You are told that the student measures the temperature of the sample of water during heating. The sample of water has a mass of 0.45 kgs. Calculate the energy to increase the temperature of water from 16 degrees Celsius to 100 degrees Celsius. And when you are given a question like this, you must be provided with the specific heat capacity. And for this case, the specific heat capacity is 4,200 joules per kg per degree Celsius. Questions like this will not miss in paper 2, and you can be asked to work out the quantity of heat. You can be asked to work out the mass. You can be asked to work out the temperature or change in temperature. Then the most important formula that you ought to remember is this formula that we are going to mention here. And of course, change in heat equals to mass times specific heat capacity times temperature change. And this change in temperature, change in theta, is usually the final temperature with 100 degrees Celsius minus 16 degrees Celsius. So our mass is given here, specific capacity is given, so we need to work out change in temperature. And this, our change in temperature in this case is 84 degrees Celsius. So having obtained that, we can now be able to go straight and put that in our calculator so that we can be able to get our answer, and then we can be able to write it down here. Now moving to the next part, we are told that the diagram shows the temperature time graph for a sample of water, and we are supposed to answer a few questions here. Use the graph to determine time taken from when the water started to boil to when the water stopped boiling. So remember, at boiling point, at that given point, when there is a change of state, there is no change in temperature. So where you have the flat graph, it means that's where boiling is taking place. So we are supposed to go straight and identify this point and this point so that we can be able to check the temperature here, and also this is 7.4, and then to get the time taken here is 4.4 minutes. And moving to the next one, this question is testing whether you understand the formula energy equals to power times time. Then we are supposed to work out the energy that was required for the water to boil. And in that case, we have the power times 4.4. Remember, 4.4 was minutes, and our time has to be in seconds. So that's why you can see I'm multiplying by 60 so that we can be able to have the time in seconds. And if we work out this, can you check with me? What are you getting? We are going to get our answer as 580,800 as the final answer at this given point. Give the reason why the liquid water should be stirred during the heating. Remember, we need heat distributed throughout the liquid, the entire part, so that when you are measuring the temperature, it can give you an accurate answer, which means that you can be able to determine the heat has been distributed in this liquid. So in order to ensure that heat has been distributed, we are going to stir the liquid so that this heat is uniformly distributed throughout the liquid. After finishing the experiment, the student removes water and the heater and places the container of water into a freezer, and then we are told that we need to so that we can be able to draw the temperature graph. How does it behave from 38 degrees Celsius to when the ice is negative 20 degrees Celsius. So you are going to see that temperature is going to decrease, and then at 0, water, because we are told the water becomes ice at 0 degrees Celsius. So there is change of state at 0 degrees Celsius until all the water has been converted to ice. So we are going to have a flat part at this given point. And then once all the ice has been formed, or the water has been converted to ice, we are going to have now the ice losing the heat to negative 20 degrees Celsius. So which means at this particular region here, this is water losing heat, and here water is changing state from liquid to solid, and at this point the ice is cooling further, so meaning there is also temperature change at that given point. If you are finding value, please consider subscribing, and also you can leave a comment down below on if the tutorial was helpful to you. Now, moving further to the next part, we are going to talk about pressure, and we are told that propane gas is stored in the cylinder at a pressure of 1.03 times 10 raised to power 6 pascals. State the formula linking pressure, force, and area. And when you are given this question, it means you are writing the formula pressure equals to force over area. Remember, force should be Newton and the area should be in meter square. The cylinder has internal surface area of 1.13 meter square. Work out the force exerted on the walls of the cylinder by propane gas. So when you are given force, pressure, you are given area, we can be able to rearrange the initial formula that we are written, so that we can have pressure is that, but now force equals pressure times area. Now we can be able to substitute the values, and our answer now can be given as what? Yes, that's what you are expected to get. And the next part, we are supposed to explain why pressure exerted by propane gas increases when the cylinder is transferred into a warmer room. Now, we know that the propane gas, all gases have molecules, and these molecules are in a continuous random motion. They collide with the walls of the container. Now, how does now increased temperature affect the pressure? Pressure increases. Now, in this question, we are supposed to justify why does pressure increase. Now, remember, when you move this cylinder to a warmer room, temperature increases, and when temperature increases, it increases the kinetic energy. So look at the situation here. We have this kind of animation here. We have particles vibrating in their fixed position. That is a solid particles vibrate in fixed positions. Yes, you can see they vibrate. When the heat is continuing to heat this solid, now the particles are free to move, so they collide. Now in gaseous state, they collide with the walls of the container. And you see, as temperature is increasing, the pressure gauge is also increasing, because the number of collisions with the walls increases. Yeah, just look at the way the particles, now when temperature increases, the particles collide faster with the walls. You see, they're moving very fast, so pressure increases. You can see that. So in this particular question, this is the concept that you are supposed to talk about, that increase in temperature increases the kinetic energy of the gases. And as the kinetic energy, the number of collisions per unit area on the walls of the cylinder increases, and this results to an increase of pressure. So there are other factors that can increase pressure in gases, of course. We can talk of reducing volume, increases the number of collision, because there is a small area over which these particles vibrate. And you can also get questions like that. So if you cool a gas, the kinetic energy decreases and also pressure decreases. Moving to part B, given that the volume of propane gas is 1.03 meter cubic at pressure of 1.03 times 10 raised to power 6, that should be power 6. Calculate the pressure of the gas if propane gas expands and its new volume becomes 2.45. Now you see, when volume actually increases, pressure is going to decrease. But in order to answer this question, we are going to use the formula P1 times V1 equals to P2 times V2. Then we can be able to make P2 the subject because we are finding P2, and then substitute what we have. If we work it out, we are going to get our answers 4.33 times 10 raised to power 5 pascals. And then you transfer here so that you can make the examiner happy. There is no extra mark for that, but that is meant to have a good rapport with the examiner. Moving to electromagnetic induction, the most interesting concept in physics. Now we go to question 3 here. We're told the diagram shows a transformer that has efficiency of 100%. So when we're told that efficiency is 100%, it means that power input equals to the power output. Unfortunately, that is the first question. State the equation linking input power and output power of the transformer. Here, we are going to say power in equals power out. Don't forget that. That's the first question that you need to remember as far as transformer is concerned. But power is given by voltage times current, which is P equals to VI. And we're going now to calculate the output current in the transformer. Now, using power in, power out, we can be able to rewrite this as V in times I in equals to V out times I out. And then in, this is the primary coil, and out, we're going to use the secondary coil. Remember, we're using out because at the secondary coil, that is where now the power is going to be taken out of the transformer. Now we need to check the voltage in the primary coil and the current in the primary coil. That's well demarcated there. That is 230 volts, so that we can be able to work output current. So output current, now we can be able to make I out the subject, and this is going to become 230 times 2 divided by 110. So if we work out this, what do we get? Use your calculator here. This becomes 4.18. So in simple terms, what I'm trying to say is, be prepared to do such kind of equation. You have to know how to work out this. Look at this question as if your life depends on it. Moving to part B, Roman 1. State the equation linking input voltage, output voltage, and turn ratio of the transformer. So here we are going to write two equations that represent this. This one can be written as V voltage in the primary coil or voltage in the secondary coil equals to number of turns in the primary coil over number of turns in the secondary coil. Or it can also be given as number of turns in the secondary coil over number of turns in the primary coil equals to voltage in the secondary coil over voltage in the primary coil. And I'm going to use this second part so that I can be able to use it to answer Roman 2, because you are supposed to calculate the number of turns on the secondary coil of the transformer, so that we can be able to use the number of turn here, number of turn that we are looking the secondary coil. We have everything. Then we need to substitute all that we have and then make NS the subject of the formula, and this becomes that. And finally we have approximately what? Use your calculator here and tell me what you got. I got 573.9, and I can be able to write this as, let me just try to write this down here, 573.9. Just can give it like that, and then we can be able to proceed the next question. Another part, explain how a step-down transformer works. We are talking of a step-down transformer. Do you know the purpose of a step-down transformer? A step-down transformer is a transformer that reduces voltage. And something else that you need to understand, you need to know these two transformers. When we are talking about a step-down transformer and a step-up transformer, they have distinctions in terms of the number of turns. So a step-down transformer reduces voltage, and when alternating current flows through the primary coil, magnetic fields, which are constantly changing directions, are created or formed. And these created magnetic fields are linked to the secondary coil by the soft iron core. As the varying magnetic fields cut across the secondary coil, a voltage is induced in the secondary coil, which results to the flow of a current in the secondary coil. So this is exactly what you are supposed to have stated in this particular question. And remember, since there are fewer turns in the secondary coil, we're going to have less voltage induced. So that is why it qualifies to be, a step-down transformer, because we have fewer turns in the secondary coil than the primary coil. Question number 4. Here I brought the concept of principle of moments, and you ought to prepare as well how to answer questions on principle of moments. And you can see here we are told that a meter rule is balanced on a pivot by 3 vertical forces as shown in the diagram below. Then we supposed to define the center of gravity. At the center of an object, you can be able to balance an object, and that object will remain at equilibrium, will remain at balance, will not topple to any side. So which means the center of gravity is a point where much of the mass of the object is concentrated. So we are going to identify that, and we are going to say that center of gravity can be defined as that the COG. Of course, that's where the COG is, because we are told it was a meter rule, it is 100 meters. So the center is going to be where we have the 50 centimeter mark. One part we have 40, we have 10, then that makes 50. So the COG is at that point. And then now we can go ahead and write this definition. This is a point where the mass of an object is concentrated. Show that the moment of the 50 Newton, that dot is misplaced. It should be 50 newtons. It's 50 newtons. Let me change that. Moment equals to force times perpendicular distance. That is the formula we shall use to work out the moment. But we need to show that, yeah, this is 50 newtons. Yes, you now have changed it. On the diagram, don't look at the equation because that was a mistake. So it should be 50 newtons. There we have a force. We have 40 centimeters and 10 centimeters and 20 newtons. So we are supposed to show that the moment of 50 newton about the pivot is 2000 Newton centimeter. So we are going to say force times perpendicular distance will enable us to work out the moment. This is going to be 50 times the distance. The distance is 40 centimeters. So if we multiply here, we are going to have 50 by 40, and this is going to give us 2000 Newton centimeter. Next, using the principle of moments, calculate the force F for the meter rule to remain at equilibrium. Now, I want you to be very, very keen here. The pivot is placed at 40 centimeter mark from one end. And when you are doing this kind of questions, I want you to be careful, because all the distances that we are talking about here are measured from where the force is to where the pivot is. So we have force F and 20 newtons. They are on one side, on the same side of the pivot. And therefore, these two forces are going to give us a clockwise moment. So if we want to work out the moment due to these forces, we are going to say clockwise moment equals to anti-clockwise moments. Now, at equilibrium, at balance, the two moments must be equal. Therefore, we need to work out a clockwise moment, and since we had worked out anti-clockwise moment, which is in Roman 2, we are going to equate them in order to work out F. But under the clockwise moment, we have two forces, so we are going to have the sum of the two moments, which means that we are going to say here clockwise moment, sum of clockwise moment equals to this one here, 20 Newton times 10, which is going to give us 200, of course. And then now we have another moment from the pivot to where the force is. And remember, from the pivot to where F is, that is going to be 60 centimeter. You need to be keen on that. That is going to be 60 centimeter, because all the distances are measured from where the force is to where the pivot is. I'm repeating that because that's the area most of the students, most of you, make mistakes. So having that is F times 60, and then we can be able to write this as 200 plus 60F. Then we can be able now to equate this to the anti-clockwise moment, which was 2000, and then this is going to be taken on the other side of the equal sign, and this is going to be 60F equals to 1800 divided by 60 both sides. We shall have our F equals to what? Equals to 30 newtons. Another question that is usually asked is what's the magnitude of the normal reaction force at the pivot? And the concept that we shall use to find that is that at equilibrium, downward forces equal to upward forces. We have downward forces that are acting on the pivot. On both sides, we have 50, we have 20 Newton, we have also 30 Newton that we have obtained. So all these forces, F, 20 Newton and 50 Newtons, are acting downward. And the force that is supporting these forces, that is preventing from the meter rule going down, is the pivot force that is acting upward. So the pivot force will be acting upward. So normal reaction force is going to be 50 plus 20 plus that, which is 100 newtons. So you see the normal reaction will be acting upward like that. So meaning some questions in some exams you can be asked to indicate the direction of the normal reaction. It will be acting upward, and that is 100 newtons. Going further to the next concept so that we can be able to check, we are talking of electromagnetic induction. We are told when a conductor carrying current is placed in a magnetic field, it experiences a force when the switch is closed. This is a concept that we learned in class, and many times most students find problems in answering questions like this. We are supposed to explain why that happens. Why does a conductor experience a force when it's placed in a magnetic field? If this is one of the questions that you usually find difficult, a question that you have found difficulty answering here, I need to give you a very precise answer that you are supposed to give. One of the facts that you need to remember, when current is flowing through a conductor, when current is flowing through this conductor, magnetic fields are created around the conductor due to the flow of current. And these magnetic fields that are created interact with the magnetic fields of the permanent magnet. So we are having two pair of fields that are acting there. Magnetic fields due to the flow of current, which are concentric and are acting around the conductor. And also we are having the fields of the permanent magnet. So we're having a set of two fields which are going to pull and push each other. Remember, when you have magnets, they push and pull each other because of the interaction of the field. And that's the same thing that is happening here. So when this happens, when current flows through the conductor, magnetic fields are created around the conductor. These created magnetic fields around the conductor are going to interact with the fields of the permanent magnet. Hence, the conductor experiences a force. That's what you are supposed to say in this particular question. Part B, you are supposed to state two ways in which this force can be increased. How can you be able to increase this force? Remember, this force is as a result of the fields of the permanent magnet, and also as a result of a flow of current. So in that way, we are going to say that we can be able to increase this by two ways. Number one, I needed to also mention this, that you can be able to determine the direction of this force by Fleming's left-hand rule. Now, by increasing the amount of current in the conductor, you are going to increase the force, and also by using stronger magnets, which are going to provide strong magnetic fields. Next, we're supposed to state two ways in which this force can be made to act in the opposite direction. One way is to reverse the direction of, to reverse the polarity, reversing the poles of the magnet, and also you can be able to reverse the direction of current in order to change the direction of motion of the force. So by reversing the terminals of the cells and by reversing the poles of the magnet, that will affect the direction in which the force is going to move. Well, also you need to remember, when both of them, when the poles and the terminals are reversed, both of them, there is no effect in the change of the motion. Explain the effect of the conductor on the conductor if an alternating source is used. In the previous section, we used direct current. Now, when we use alternating current, there is something that is going to happen. Remember, alternating current keeps on changing size and direction. So the fields that are going to be created when using alternating current are going to be changing size, magnitude, and direction. So the conductor will vibrate up and down, and this is because the fields created by the alternating current are constantly changing size and direction. So the conductor will vibrate up and down. Now we're going to talk about this simple electric motor. These are also some of the questions that are usually tested. We are supposed to identify a few parts that we have here. We have a metal or graphite brush in contact, and this is for conductivity and also reducing friction, because these commutator are sliding. The commutator are there to reverse the direction of the current so that the motor continue moving in the same direction. We have also the permanent fields, the permanent magnets, which are going to produce the magnetic fields. And we have also the flow of current in this loop, and when current flows through this loop, magnetic fields are created around that loop. Now you see, since we also have fields of the permanent magnet, the two magnetic fields. Magnetic fields due to the flow of current in the coil, and the fields due to the permanent magnet, they are going to interact, and then there is a force, as we had mentioned earlier. So we need to try to talk about this, and I want to identify this coil A, B, C, and D. And you can see in one arm currents moving up, on AB currents moving towards us. Now explain how an electric motor works. Now when electric motor switch is switched on, current flows through the coil. Now we have fields, of course, created here, and there is this magnetic field of the permanent magnet. So when current flows through this, AB is going to experience an upward force. When current flows through the coil, AB magnetic fields are created around it, and those magnetic fields interact with the magnetic fields of the permanent magnet. Hence, the part AB is going to experience an upward force, while CD is going to experience a downward force. Now we are going to have a rotational motion at the loop here. Yeah. Now you see, this is another part. We can talk of electric motor. We can also be tested on DC generator. Now you see, we have a magnet, we have a bulb somewhere there. So if we happen to rotate this loop, the loop is going to cut across the magnetic fields. As it rotates, it will be cutting across the magnetic field. Now when the loop cut across the magnetic field, electric current is generated in the conductor. A generator produces current, but a motor uses current to bring about rotational motion. So when a wire cuts across magnetic field, a voltage is induced in a wire through electromagnetic induction. Now, stage 3 modification that can increase the speed of the rotating coil. Now, to increase the speed, we can be able to do that using a stronger magnet, also by using more coils, or we can increase it by increasing the amount of current in the coil. That's what we are supposed to do. E, we are told the diagram shows a loop of wire connected to a power supply, and we're supposed to describe how to find the magnetic field produced by the loop of wire. The easiest way to describe the magnetic fields forms around this piece of wire or loop of wire is by using iron filings. We are going to sprinkle iron filings on the cardboard. Now, once we have sprinkled these iron filings, we are going to tap the cardboard. Then once you tap the cardboard, these iron filings are going to arrange themselves in a regular pattern. And this pattern now is the one that displays or represents the arrangement of the magnetic fields around this. They are circular, concentric, and they have a very beautiful pattern like that. Now, the next thing that you ought to do in order to get your final mark, you need also to indicate how do you determine the direction of the magnetic fields. So to determine the direction of the magnetic fields, of course, you are going to use a plotting compass. Now, this is what you are supposed to write: sprinkle iron filings on the cardboard. And next, you need to tap the cardboard gently. And then what do you notice? The iron filings are going to rearrange themselves to form a regular pattern. This pattern that is formed around the conductor represents the magnetic fields due to the flow of current. Now, to determine the direction of the current, we are going to use plotting compass in order to determine the direction of current. I believe you are getting value from this video. Please consider subscribing, even though maybe you are doing your final exams. Just the best thing, the best present you can give me as per now is by just subscribing and liking this video, and so that YouTube can be able to recommend this video to others. Even if it's not going to be of help later on, just please subscribe that, give me that present of subscription. I will also be motivated to create more for others, and at the same time, this channel is going to be a concoction of also A-level videos. So I believe later on you are going also to benefit. We are going to have maths videos, physics videos for A-levels. So please, that's why I'm requesting you give me that subscription. The next part, you are supposed to draw the way the patterns are around here. That's what we're going to have, and then we're going to have the direction of the field, which you can be able to use right hand grip rule. Right hand grip rule is the rule that you use to determine the direction of the fields around this. Now question number 6, we are told a student uses an oscilloscope to determine the speed of sound. So meaning you have to prepare on how to determine speed of sound using different experiments to determine speed of sound. This is one of them, using a CRO. There are other experiments like using echo method, whereby you stand a given distance away from the wall, you produce a sound, and you determine how long it takes to hear the echo. And when you're using that experiment, you need to use a meter rule or a tape measure to measure the distance from where the wall is to where your position is. And also you need to have a stopwatch to determine how long it takes to hear the sound. Now, at that given point, you are going to use the formula speed equals to 2 times distance over time, because sound travels twice the distance. It travels to that point where the wall is, then back. Another experiment for sound determination is when 2 people standing distances apart, a given distance, maybe 100 meters is the standard distance when you're using that method. 2 people standing 100 meters apart, one produces the sound and the other also stops a stopwatch once he or she hears the sound produced. Errors in those experiments can be reaction time, error due to stopping the stopwatch, or error due to measuring the distance wrongly. That can also be tested. Now back into this question, using a CRO, we are having the Y direction. The Y direction is giving us the amplitude. X direction is going to enable us to get the periodic time. Time is on the X direction, and remember here we have time in milliseconds. 1 square is 1 millisecond. What does that mean? 1 millisecond is the same as 1 divided by 1000. So that you work out the time in seconds, you need to divide 1 by 1000. Now the student uses 2 microphones. A microphone is also required here, and some question you may find they are asking you which other apparatus is required. At that given point, when you're given that question, additional instrument is a microphone, which is mentioned here. All right. So when this experiment is performed, 2 microphones are used like that, and now when you measure the distance between the microphone, that represents the wavelength. Now we are supposed to state the formula linking speed, frequency, and the wavelength of a wave, and we're going to say speed equals to frequency times wavelength. Frequency has to be in hertz, and wavelength has to be in meters. You have to remember that. Always use the oscilloscope to calculate the speed of the wave. We are using the formula that we have stated. Now we need to work out the periodic time, and period time is time for 1 complete oscillation, 1 complete cycle. So we have 1 complete cycle when we have 4 squares. So times 1 millisecond, that becomes 4 times 1 millisecond, that becomes 4 milliseconds. That's the periodic time. But remember, our time is in milliseconds. So what are we going to do? To get the time in seconds, we're going to divide by 1000. So our periodic time for one complete cycle is 0.04 seconds, and we know that frequency is 1 over period, which is going to be approximately 250 hertz. Now we can go back and work out the speed. Our speed is frequency times wavelength, which is going to be 250 times wavelength, which is 1.4. It was given there, and when you work out that becomes 350 meters per second. I believe you've understood how to work out such questions. Please comment down below, give this video a like. Differentiate between renewable and non-renewable energy resources. When we are talking about renewable and non-renewable energy resources, these are two energy resources that we discussed in our lessons. And we say that energy resources that do not deplete, that can never be finished, that can never be used up, are renewable energy resources, which we can define as energy resources which can be replenished, can be replenished once used. They are regenerated naturally. They are never used up. So examples include solar, we can talk of geothermal, we can talk of hydroelectric power, we can talk of wind power, we can talk of tidal power. So these are the renewable. So you need to understand this definition, and also you need to understand advantages involved in these types of energy resources. Now we can talk of non-renewable energy resources, which are type of resources which cannot be readily replaced once used up. Once you use them, it takes a longer period of time to replace them, or you cannot even replace them. Examples include nuclear energy, coal, we talk of natural gas, we talk of fossil fuels, and many others. Yeah. Then you also need to understand advantages and disadvantages of using this non-renewable to the environment, and also the advantages. So basically you need to go straight and check those advantages, disadvantages, and advantages before you sit for your exam. The photograph shows Green Georges Dam in China, one of the largest hydroelectric power stations on Earth. State 2 advantages of generating electricity using electric power station. What are the advantages? Number 1, it's sustainable and is renewable form of energy. Yeah, is renewable and sustainable. We can talk it's clean and environmental friendly. It does not produce harmful gases. It does not harm the environment. So it's clean and environmental friendly. It does not produce CO2. That's one of the advantages. It does not contribute to global warming because that does not produce greenhouse gases. It can produce energy to meet the drastic and immediate demands. Yeah, we can also talk about it can generate. It has a low maintenance cost. So even though the capital of starting an hydroelectric power station is high, but now after you have built it, after the country has built it, it has low maintenance costs. And it has a long span. It can serve people for a long period of time. Okay, let's move to cosmology. Let's move to another astrophysics concept. Now, do you know the origin of the universe? Do you know how the universe began? The universe has a very long history. There are different theories that explain how the universe began. Right from our religion, our traditions, And science also have its own perspective, how the universe began. In the specification, we are going to base our argument in the Big Bang Theory. Big Bang Theory claims that the universe began about 13.8 billion years ago, and the universe expanded from a single incredibly single short small dense point, and that point was very hot, so it expanded to become the universe we have. So Big Bang Theory still claims that the universe is still expanding. So what's the fate of our universe? If something is expanding and it continues to expand, it will reach a point where that thing's going to explode. So I believe we are going to live and see that happen. But for today, I want us to talk about how cosmic microwave background radiation CMBR supports Big Bang Theory. So when you're given a question to show how the presence of cosmic microwave background radiation supports Big Bang Theory, what are you going to say? I believe this is a candidate question. This is a pregnant question that can be given birth in an exam. So according to Big Bang Theory, the universe originated from a hot, dense point that expanded to become a universe. Detection of cosmic microwave background radiations of short wavelengths spreading from all directions serves an evidence by the claim that they might have an indication that they might have been created during Big Bang Theory, during the explosion. So since we are able to detect this cosmic microwave background radiations everywhere in the universe, spreading in all directions, so we tend to imagine where they might have been created during the explosion. So this is the evidence. Part B, you are supposed to describe how the size and temperature of the universe has changed since Big Bang Theory. We say that the universe, according to Big Bang, the universe originated from a small, hot, dense point, which expanded, and the universe is still expanding. So how does that affect the size and the temperature of the universe? So initially, the universe was incredibly small and dense. Since then, the universe has expanded and cooled down. So this results to the increase in size of the universe and decrease in temperature. Part C, discuss two pieces of evidence that supports Big Bang Theory. We have already mentioned them, but I brought this question up so that maybe one of them can be asked, so that you know exactly how to approach it. When I'm putting these questions, I'm just giving a concept so that when a question is asked, you know how to approach it. It also can be asked like this. And we have two evidence. We have the existence of cosmic microwave background radiations, and also we have the redshift that is observed from distant galaxies. So existence of cosmic microwave background radiations, CMBR, appears to be the same everywhere and acts in all directions. They might have been originated from Big Bang Theory, so during that explosion. So when we see that, we can be able to see that indeed the universe might have originated from Big Bang Theory. The next evidence you are to give is the redshift that is observed from light emitted by distant galaxies. So this redshift indicates that the galaxy is moving away which means that the universe is still expanding. And remember, this is an assertion. This is a claim of Big Bang Theory. Big Bang Theory says that the universe is still expanding. So when you see the redshift, that galaxies are moving, it means that still the universe is expanding. And indeed, we can be able to confirm that. Next particular question that you can be asked in order to answer, we talk about Doppler equation, Doppler effect equation. Now, we are told that hydrogen gas in the lab on Earth emits light with a wavelength of 605 nanometer. A distant galaxy contains hydrogen, which emits light on the same wavelength. Now, it emits in the same wavelength, but when that wavelength is observed from the Earth, it's seen to be 683 nanometer. So you can see there is a change, there is a shift in wavelength. Remember, Doppler effect is the change in frequency or change in wavelength when the observer is moving relative, when an object or when the source of the wave is moving relative to the observer. So since the universe is moving, we are going to detect a different wavelength. And now, in order to do that, we are observing the universe from Earth. Then we have the light that's emitted. So when you observe the wavelength of the light emitted by hydrogen has a different wavelength, and that is now Doppler effect. Doppler effect is the change in frequency or change in wavelength when the source of a wave is moving relative to the observer. So we are supposed to calculate the speed of this galaxy. Now we're going to use the formula change in wavelength over the reference wavelength equals to velocity or speed of the galaxy over the speed of light, which can be written like this. So the change in wavelength can be subtracted. We can be able to subtract these two in order to get the change in wavelength, which is going to become 78 nanometer. Now, once we have that, we can be able to substitute into the formula. We have this is the reference wavelength, which is lambda naught, and we have the formula, and then we substitute. So the speed of the galaxy is going to be 3.87 times 10 raised to power 7 times 10 raised to power 7 meter per second as the speed of the galaxy. We have come to the end of this particular video. I believe you've gotten value. Continue revising for your exams, and my humble request is for you to give me that subscription. I'm going to prepare still another clip which will be dealing with topics that never appeared in paper 1, those topics that were not in paper 1. So there are high chances they will be tested. HR diagram, Hertzsprung-Russell diagrams, stars or evolution of stars. How do stars larger than the mass of the Earth evolve? That's the next video I'm going to upload in a short while. Otherwise, all the best for your exams, and subscribe. If you want to check that video I've mentioned, I'm going to add a link in the description in this video. See you next time.